All right. So today we are learning about factoring, or we are starting the unit of factoring. So we are reviewing. Most of this is just review. However, I'd like to go over how to find a GCF. It's one of the more important things that we do. GCF is your greatest common factor, and it's always the first thing that you need to look for. First thing. So whenever you're factoring, it's always the start. Okay, this will never leave you after today in this class. So greatest common factor is a term that divides evenly all other terms. So first we have to know what a term is, and then we have to find the greatest common factors of all the terms that we have. So to find that, first find a number that divides evenly into each term. If no other number, then we pick one. And then the second thing is you find a variable that's in each term. And then the easiest way to think about it is you always pick the lowest exponent of that variable. It's just so that when we divide, we don't have negative exponents. So let's look at an example. All right. So looking at this first example, we have 8x cubed. Whatever, I don't need to read it. You can read it. So we have three terms here. This is the first term. This is the second term. And this is the third term. So we went over what terms were. And when we factor, what we do is we basically divide out anything that's common. Well, that's what I said. It divides out anything that's common. So what we want to look for, the first thing we look for is the numbers. So we look at all three numbers, 8, 2, and 4. Looking at those numbers, a number that divides evenly into all of them would be 2. Okay, so that's our number in our greatest common factor. Now we have to look if there's any letters that might be in there. So we look here, there's 8x cubed, or there's x cubed, x squared, and x squared. So x is in all this first, second, and third term. It's in all three terms, so x is in there. And then we pick the lowest exponent on that variable. So it's got a 3, a 2, and a 2, so 2 is the lowest exponent. Then we find the next letter. Y is here, here, and here. So y is in all three terms. So we put a y and we look at the exponent. It's got a 3, a 2, and a 1. So y to the first, or just plain old y. Then we find there's another variable. So z, no z here. So if there's no z, then z is not in the GCF. It's got to be in all three or all four or all two, however many terms there are. Okay. Basically what we're doing is we're going to factor that out, and factor that out just means divide. So we're going to take each one of these and divide that by 2x squared y. All right, and when I divide that, I'm going to have whatever I divided by, and whatever I get when I divide by, I'm going to have another three terms. 1, 2, 3 terms. Because however many terms you have in the original, that's how many terms you're going to have in the parentheses. Okay, this number of terms should always match. All right, now we just divide and put the answer here. So 8 divided by 2 is 4. 3 minus 2 is 1. And 3 minus 1 is 2, so that's y squared. And z, there's nothing to change z, so it's just stays z. And that's all we do. So that dividing that we did a couple weeks ago, it's the same. We use that here. So 2 divided by 2 is 1, positive 1. X squared and x squared, these cancel out. 2 minus 2 is 0, so there's none left. And then y squared and y to the first, we're just left with a y, and z again, nothing to change it in the GCF. And then finally here, we have 4 divided by, or negative 4 divided by 2, so that's negative 2. These cancel out again, and these cancel out again, and so we're just left with, I'll rewrite it for posterity, 4x squared, xy squared z, plus yz minus 2. So this is, we've factored out the GCF. Okay, I'll do the next one a little faster. So find the GCF. So that if you look at all three terms, there's 1, 2, 3 terms again. So 3 goes into all of those numbers. A is in all three. The lowest exponent on the A is 2. And the lowest exponent, B, is in all three again. And I don't understand why I put a parenthesis there. Hold on. So it's 3a squared b. B's lowest exponent is 2. So it's 3, 2, and 2. So its lowest exponent is 2. I divide by it. 3a squared b squared into both of them. And that's what's put into parentheses. So we always have to have 3 terms because we had 3 terms to start. This is 1, this is 2, this is 3. Okay, so when we divide, we get 1 a to the 4th b. Remember, I'm just subtracting the exponent, 6 minus 2, 3 minus 2, minus 3a. So the b squareds cancel out here. We're just left with 1. So that's it. And then this one, the 3 cancels out, the a squareds, and the 2. But remember, we do have to have a third term here, so we will put a 1. So that's your final answer there, factoring out that GCF. Pretty darn exciting. Okay, a couple more examples. So sometimes it's not going to have a letter. So if you look here, we still have 3 terms, but so we look at the number, there's a 2 goes into all of those, but if you look, there's an x in the first, an x in the second, but no x in the third, so that means that x is not going to be in the GCF. That's okay. Sometimes you don't even have a GCF. Sometimes there's nothing that divides. We're going to live through it. It's going to be okay. And then just divide. So all I did was divide here. 4 divided by 2, negative 2x. 8 divided by 2 is 4. All right, also same idea. We're finding the GCF for this guy. There's a 1, a 3, and a 1. So the GCF, we can say there's a GCF of 1. Sometimes we don't write it, but if we like to, we can. But we do see that x is in here. X is in all 3. And x to the 5th, 3rd, and squared. So it's x squared. And now we just divide. There's no numbers to divide, so we're just subtracting exponents. So 5 minus 2 is 3. 3 minus 2 is 1. We keep that 3. And then x squared divided by negative x squared divided by x squared is negative 1. Remember, there's 1, 2, 3 terms, so I have to have 1, 2, 3 terms. If somehow you lose that 1, you lost a term. Sorry, I just don't know why that's funny. This one's weird. I just want to give you a look-see and show you that terms are always separated by plus and minus signs. But if you can see in here, this guy, this whole term goes this big. One of its factors, is instead of like a y there, is x minus 1. So, interesting. It's just things that happen. Okay, so we do have binomials that can be factors. There's only 2 terms here, 1 and 2. So again, we look at the numbers. 2 goes into 2 and 6. We look at x's, x and x. The highest exponent on the x is x to the first. So we can, yeah, so we're good there. And then we have x minus 1 is also a common in both. It has no exponent on it. So since there's no exponents, it's just plain old x minus 1. And now we just divide. So when we divide, this is our GCF we're dividing by. So it looks really weird, I'm not going to lie. But that's all it is. It's the same thing, you just have to see that, I guess. 2 divided by 2 is 1. 2 minus 1 is 1. So we just have x to the first. So the 2's cancel out. X minus 1 is the same on the top and the bottom. And then the next one. So we're just left with x. And then 6 divided by 2 is 3. X divided by x just goes away. And x to the first, x minus 1 and x minus 1, that goes away also. So we are simply just left there with net minus 3. So we have this crazy answer as that. All right, that's the GCF. Enjoy. Remember, if you multiply this back out, if you distribute that in, you should get the original. Okay, so that means that however many terms you start with, that's how many terms you should end with. Otherwise, you're going to not have enough when you multiply it into check. All right, have a wonderful day. Adios.